Hello everyone, I am Mahmoud Behrouzi from Tehran University. I am going to calculate the land use change and carbon sequestration in the InVEST software. The ecosystem stored the carbon spatial in the vegetation and green land use, but climate change by global warming dried this vegetation, spatial destroyed the forest, also human by land use change eliminate and destroy the forest, then carbon emit and release and import to atmosphere. We will calculate and measure the effect of land use change on the carbon storage and sequestration by InVEST software. At first, in the ArcGIS, we must create and prepare in the land use raster the drive D, the carbon sequestration LULC, and the LULC for 2001 year.tif. Okay, the right click on attribute table. It must have a two field in the LULC name. Okay, backend, crop, forest, urban, and the waterland, and LU code. LU code, this is important because this need for the carbon pools in the Excel format. Okay, and LULC for 2025 years. Okay, right click, attribute table is the LULC name and LU code. Okay, and we need the carbon pools. This table need to import the InVEST software and the column or field LU code, LULC name, and carbon pools, the four pools. Okay, in the Google search the carbon sequestration InVEST in the Stanford University for the carbon, the description in the carbon model and user guide carbon, description and summary of model to calculate the carbon storage and sequestration in the InVEST, introductions, the model, the four pool carbon in the vegetations, above ground on biomass or canopy of tree, and below ground biomass is the root tree, and the death matter is the dried leaf and branch of the trees, and soil sediment is the organic matter in the soil that is sequestration and storage the carbon. Then four pool carbon in the vegetation that this need import to this table in the Excel by CSV format and import to InVEST software. Okay, LU code and four pool carbon and the carbon storage in the metric ton per hectare, per 1 hectare. Okay, in the vacant or bare lands storage in the canopy above ground, 10 metric ton carbon per hectare. In the below, in the root is 20 metric ton carbon storage in the hectare, and the soil organic matter 10 metric ton carbon, and death is the 5 metric ton carbon in the hectare. In the cropland 2, 1, 10, and 0. In the forest, the high mass carbon storage in the above this is the matter above ground in the canopy, leaf, branch, and other canopy of vegetation and trees. Above in the forest is 300 metric ton carbon per hectare for forest land. For urban, 0 in the soil of urban organic matter life in the soil is the 10 metric ton carbon per hectare. Okay, for water is 0 for 4 pool carbon. Okay, this table for Excel and CSV format need to import to InVEST software. Okay, in the start window write the InVEST, enter. We will wait the InVEST software. Okay, InVEST have a 20 module for calculate the ecosystem service and trade-off. Okay, 20 module and the carbon storage and sequestration click and workspace directory folder, the drive D carbon folder, no, in the carbon sequestration folder, new folder by output. Okay, double click and the folder output, select folder, and the file suffix is the test1, test2. Okay, baseline. Okay, we will calculate the effect of land use change. Then we need to land use change and the 2001 to 2025 years. Okay, baseline raster is the folder carbon sequestration LULC LC underline 2001.tif. okay, in the ArcGIS this raster. Okay, and the attribute table LULC need to this table and in the table of Excel format. Okay, then in the baseline LULC is the TIF format. Okay, carbon pools, the Excel is the CSV format. Okay, this table LULC setting by raster file LULC and the 4 carbon pools. Okay, in the InVEST carbon pool CSV format, carbon sequestration carbons underline pool dot CSV, open. Okay, calculate sequestration, yes, active. Alternative raster for 2025 years raster files LULC LC underline 2025.tif, land use map. Run valuation model for the price carbon and price and discount rate. Okay, yeah, active. Baseline LULC year 2001. For alternative LULC year is 2025 years. Price carbon in the InVEST and Stanford University carbon price. This $100 for metric ton capture carbon. Okay, I think this day in the 2025 years the carbon price carbon price, I think $342, I think. about this European carbon permit. Okay, this so for euro, no, for dollars. Also, we import the $100, no problem. In the this description, write about the carbon price. For example, this World Bank is the standard reference. Carbon tax instrument and the American conditions, the credit. I think this 2025 years the carbon price for capture carbon is $342. But in the InVEST software, write the cost of this technological per metric ton capture and storage approximately $100. Okay, no problem. Price carbon is $100. Annual market discount between 7 to 12%. I think write this. Okay. Some economy believe that the market and consumption discount rate of 7 to 12% for discount rate of carbon. I imported 10%. Okay, 10%. Okay. I full workspace directory and file suffix test2 baseline LULC raster file 2001 carbon pools is the Excel is the CSV format. Carbon sequestration alternative for 2025 years. Run valuation for baseline price carbon and then the discount rate of carbon. Okay, everything is ready and run click. I will wait running the carbon storage and sequestration, and output is the raster file and import to ArcGIS. I will wait. Yeah, model complete for carbon storage and sequestration, and open workspace, carbon sequestration output folder. This is the output of carbon storage and sequestration by InVEST in the TIF and raster file output, intermediate output. See above alternative. Alternative is the 2025 years, and baseline baseline for the 2001 years. Okay, see above and see below, see depth and see soil. Okay, in the ArcGIS we add data, the output of InVEST model. Okay, ready, carbon sequestration, right click, refresh, output. Okay, and the C is that all carbon. Okay, all carbon storage in the baseline baseline year. Okay, all carbon sequestration. Okay, in the 2001 years, okay, baseline years 0 to 720 metric ton carbon storage in the 1 hectare. Okay, color standard about the high carbon storage in the forest. This is the forest, and LULCA 2001. Okay, forest is the green color, carbon storage in the baseline, and the height carbon storage about 720 metric ton carbon storage in this in the forest area. Okay, but in the urban area, okay, it's urban, the Saudi city is the low carbon storage. And in the 2025 years, in the alternative, all carbon storage and sequestration in the area for alternative 2025 years. Okay, this year's is the carbon high carbon storage in the 720 metric ton carbon in the hectare, and the high carbon storage in the in the forest land. Okay, but in the urban land, zero carbon storage. Okay, and the change, this is very important, the change in the baseline and alternative in the 24 years from 2001 to 2025 years, and the change carbon storage, this is very important. About the color map. Okay, in the green pixel, okay, the green pixel, the carbon storage added and increase in the 24 period. Okay, and the change 720 metric ton carbon storage and sequestration in this area, because in the LCA 2025 years, okay, this pixel, because this pixel this area in the 2001 year is the vacant, okay, and urban, but in the 2025 years, this area is changed to forest. Okay, because in this area the purple color pixel is the destroyed the forest, and carbon storage is negative. Okay, this pixel, because destroyed the forest and the release and emitted the carbon and imported to the atmosphere, into the atmosphere. Okay, this change baseline and alternative years is very, very important. Okay, now in the carbon baseline, right click, symbology, classify, okay, in the ArcGIS desktop, we have a solution for all carbon sequestration in the baseline and alternative years. We will wait ArcGIS desktop. In the ArcGIS Pro, we import the rate NPV rate for dollars, the carbon sequestrations. Okay. For ArcGIS desktop, okay, add data, in the drive D, carbon sequestration output, and the all carbon storage in the baseline 2001 years. Okay, right click, properties, the symbology, classified and classified. The sum of carbon storage in the study area for the 2001 years is 207 million metric ton carbon storage in the study area. Okay, in the Excel, okay, 2001 year is the 207 million. The carbon storage, okay, but in the 2025 year, okay, right, add data and storage, all storage in the alternative years. Yeah, alternative, right click, property, classify, again classify. The carbon storage is the sum carbon storage. Okay, we calculate the difference between the 24 years. Okay, this pixel negative, the 2025. Okay, and 30 million carbon difference, carbon storage and carbon emitted and decrease and increase in the atmosphere. Okay, the 24 year difference. Okay, difference in the 24 years and the carbon emitted and into the atmosphere. The reason is the land use change in this period. Okay, and add data, NPV for dollars. Okay, in the color standard. In the red pixel is the rate of carbon NPV and import and uh, emitted the carbon and into the atmosphere from the red colored pixel. Okay, and NPV and difference carbon change, all carbon change, baseline and alternative years, add. Okay, and properties symbology is the classify, again classify about 34 million ton carbon emitted and into the atmosphere between 24 years from the 2001 to 2025 years. Okay, in this sum near to this, okay, 13 million and 34 million, and the difference carbon storage in the 24 years period. Okay, you can layout in the output the carbon storage from InVEST software. Thank you for much. Have you questions? I I try to reply to your question. Thank you.